In the previous video, we looked at how to use the LLDB command language for debugging. In this video, we're going to take a look at Xcode's address sanitizer that works with Clang-based languages for detecting deeper memory problems. The address sanitizer is a feature for languages using the Clang compiler that allows you to better find memory issues such as buffer overflows, use after free errors, double free, and other memory corruption bugs at runtime. This is helpful for when interoperating with languages like Objective-C or C. Since Address Sanitizer doesn't work with Swift alone, we'll need to put our interoperability knowledge to work to create a memory problem. Let's open up our previous project and we'll add a new file to our project's root folder. Select iOS, then C file, click Next, give it a name, and save. I'll paste in the simplest function that will result in a buffer overflow for the address sanitizer to pick up on. Next, we'll create a header file with the same name. Select iOS and choose Header File. Click Next, name it, and create. This file will just reference our buffer function. Finally, we'll add a bridging header file. Select iOS and then choose Header. Click Next, name it the same name chosen for the application, then dash, bridging, dash, header. If you need a refresher on bridging headers, revisit Section 4, Interoperability and Working with Third-Party Libraries. Next, click on the root application and select Build Settings. Then scroll down until you see Objective-C Bridging Header. Click the blank field and a pop-up appears. Then drag the bridging header from the project navigator into the dialog and you'll get a file path, and then just delete all of this text. We'll create a memory problem in our sum function method by calling our buffer function. If we run the application, we get an error that takes us to the app delegate, but that's the extent of the detail that we get. Let's enable address sanitization by clicking Edit Scheme, then Diagnostics, and then by clicking Enable Address Sanitizer. Xcode will know to rebuild the application with address sanitization, allowing us to capture more details at runtime. If we build and run our application again, we'll see a much different error. This time, we are taken to our C code and shown right where our error lies. We're also given an extensive stack trace revealing quite a bit of details. We get even more details in our debug navigator. We can see that our memory issue occurred 15 bytes after a 2-byte heap region at this location. We can click any of these events and walk through the thread's process frame by frame to learn more about the problem. We can get a more granular view of our memory by clicking on the address here to see which portions of our memory are valid or invalid. This is our memory view. Everything that we see here that's grayed out is invalid, while everything that is not grayed out is valid memory. Again, this can be a very handy feature when interoperating with C or Objective-C. To learn more about address sanitization, please visit this video's resource page. Address sanitization is a pretty cool feature. We saw how enabling it can improve the error message while interoperating with Objective-C or C. In our next video, we'll look at another useful debugging technique by using assertions.